Okay, now before we start it, okay, I try to see how you will be doing on the assignment. Okay, first thing, I just try go over with you number 1 to number 5. Okay, okay, now go ahead and do number 1, telling me the answer. This one, I already given you the formula. Okay, who get the answer for number 1 and let me know.
Thirty-one point six.
What?
31.6.
Perfect. Right answer will be 31.6. Then number 2.
The number two, I get 1.58.
Yeah, you did very good job, man.
Thank you.
1.58. Okay. And number 3.
Number 3 is 7.78.
Mean number 3.
Yes, sir.
Who else?
I got that one too.
What'd you get?
7.86.
Who else?
I'm a little off. I got 32.21 decibels.
You mean 32.2?
Yes, correct.
Perfect.
I got 3.256.
Who else? Make sure you know you have to calculate the AP1, that's 20, that's dB. And you calculate the AP2, 5 dB. Okay? The gain of the ordinary power gain will be multiplied. Okay? dB gain you're adding up. However, ordinary gain have to be multiplied.
$16.2.
What?
316.2.
316. Perfect.
Yeah, I got two.
Sorry. Okay. That one.
I think I got 3.16.
Who else?
Yeah, 316.
Not yet. You know the formula for dB, V. Twenty times log V1 over 1 volt. And they will be equal 0 dB. 0 dB volt. Okay? Then the log
6.2.
perfect. That's the answer. Okay? That's it. Okay, the next I will be go over quickly for you before we start with the differential amplifier. Okay, only thing you can do is the transistor amplifier. When you're looking into the circuitry, and you have to know what that amplify. Common emitter, common base, common collector. Okay, so this is a common emitter. The thing is, input apply to the base, output from collector. And the second thing, input go up, output going down. That means they will be opposite or 180 degrees our phase. That's only thing I want. Make sure you don't have to do any calculation. However, when you're looking into the transistor amplifier, you have to know the common emitter, common base, or common collector. Okay? And this is the common emitter. Input applied to the base, output from collector. And the input output 180 degrees or phase. That's what I want you to make sure. You know that. Okay, now next one will be common base. Common base input applied to the emitter. Input applied to the emitter. Output from collector. Okay? And basically, input output will be in phase. Okay? You can see summarized right here. No phase inversion. Input and output. That means input go up, output go up. Input going down, output going down. Okay? Okay, just a minute, okay? Okay, now we start with the differential amplifier. A differential amplifier is a bipolar junction transistor amplifier that produce output that are function of difference between two input voltage. Okay, so the first thing you're looking on this schematic here, you get two transistor Q1 and Q2. You get the input 1, you get input 2. Okay, and the output will be output 1 and output 2. That's what they call a differential amplifier. And this is the symbol. Okay, this is the amplifier. Input 1, input 2, output 1, output 2. Okay, so when you see this signal here, this amplifier, then you have to understand this is a differential amplifier. Two input and two output. Okay, and assume both transistors are identically. Q1 or Q2, same thing. RC1, RC2, same thing. IE1 equal IE2. Okay, IE1, IE2. Okay, and equal the current IRE divided by 2. Okay, where IRE equal VE minus VEE divide RE. Okay, and VC1 and VC2. Okay, equal VCC minus RC1. That's normal. Okay, VE equal VB minus 0.7. The thing is, you know that is the VB. This is the 0.7 for the diode. So that's why VE equal VB minus 0.7. Now, first thing you see, If they routed input 1, they route input 2. They measure the VC, and that VC1 or VC2 identical for both input routed. Now, for this configuration, sine wave connect to VB1. That means you get a sine wave. Connect to VB1. And they routed for input 2. Okay, we'll see what happened. Sine wave connect to VB1. Q1. Okay, what the configuration of Q1? For the Q1, input to apply to the VB, output from the collector. So what the configuration for Q1?
It's going to be common emitter.
Perfect. Common emitter. And if common emitter, then the output at the Q1, they will be opposite, correct? That means at the output of Q1, they will be 180 degrees out of phase for common emitter. Okay? And now you can see the sine wave. In here, you can get the sine wave. In here, you can get the sine wave. Okay, what the configuration for Q2? So we know that the CE. What the configuration for Q2?
Common base.
What common?
Base.
Right, common B. Input applied to emitter. Output from collector. And basically, we already know input output will be in phase. Okay, so the output here will be in phase. When you're looking into this circuitry, that's only thing what you need to know. Okay, when they already telling you right here, Q1 CE amplifier, input, output, inverter. Okay, VB2 is round, Q2 is common base, and input, output is in phase. If you can understand up to that point, you're okay. Okay? Now let's see what else. So that one, they will be applied input into Q2, and Q1 input will be routed. just a reverse of the other one. Okay, then you understand in this case, Q1 will be CB and Q2 will be CE. Okay, that's what they already telling you in here. Okay, sideway connect to VB2, Q2 is CE, input output will be inverted. Just a opposite to the one you just see it. Okay. Now, let's see. This is they apply to Q1. Okay. You see they get the input sideways here. Output will be opposite, reverted. And Q2 will be CB. Input, output will be in phase. That only thing they emphasize to make sure you know that. This is just try to revert it, okay? Now, mode of signal operation. Single-ended input. That means they apply only one input, the other one they route it. Okay? So you can see output 1, okay, they will be inverted. Output 2, they will be in phase. Okay? When a different amplifier is operate in this mode, one input is ground and the signal is applied only to the other input. Okay? That means one they apply for input 1, one they apply for input 2, and they draw the output for you. Now, differential input. Now they apply the input 1 and also input 2. Okay. Only thing you have to pay attention. Input 1 and input 2 must be opposite. They must be two opposite polarity or our phase signal are applied to the input. That's a requirement. You cannot apply the same signal, same phase in the input 1 and input 2. Okay? And that will be telling you the output 1 will be this side. Okay? The other one will be opposite. However, they want to emphasize in here. That means two input, they must be opposite. Okay? We say common mode input. Okay? Both inputs are the same phase, same frequency, same amplitude are applied to two input. That means this one identical. Okay? The output are superimposed and they are cancelled, resulting in zero output. Okay? So now, if you apply two input identical, output will be 0. That will be telling you one thing. normally that will be deal with the noise. Okay? The noise, that means the unwanted signal. Okay? At the input, amplifier look like the identical signal, they will be considered to be the noise. So that's why they cancel at the output. Okay? This action is called common mode rejection. Okay? Common mode rejection means that this unwanted, that means the noise signal, okay, will not appear on the output, the desired signal. Common mode signal, that means the noise, generally are the result of the pickup of radiated energy on the input signal line from adjacent line. So basically, if in the both input get the identical, so the op amp consider that to be a noise, and they will be canceled out. So that's why the output will be 0 volt. Okay. Common mode rejection ratio, CMRR. The measure of the amplifier ability to reject common mode signal is parameter called common mode rejection ratio, CMRR. And CMRR formula will be equal AV, that means the gain, divide AC, that means the gain of the differential amplifier and the gain of the common mode. Okay? Where AV, differential voltage gain, ACM, common mode gain. Okay? The higher CMRR will be better. Okay? And CMRR is often expressed in dB, and that will be in dB. They will be equal 20 log of AV differential divide AC common mode. Okay? So that's just a formula to calculate the ratio between signal you want and signal you don't want. Okay? Now try to see example. A different amplifier has two differential voltage gain and a common mode gain. They want to determine the common mode rejection ratio and express it in decibel. Okay? Try to see how they calculate. CMRR equal AVD, differential gain, divide ACM, 2,000, divide 0.2, get 10,000. And you change that 10,000 to the decibel. CMRR, 20 times log of 10,000. Answer will be 80 dB. Okay? Now what I want you to doing that example for me. Go ahead and do and give me the answer. That's a very, very simple. Just apply to the formula.
$90.6.
Okay. 0.6 what? 0.6 dB or what?
Is 90.6 dB.
Let's see.
I got 90.62 dB.
Huh.
At 19.6.
19.6. Okay, let's see. CMR.
I got 80.
Okay. That will be equal. Okay, ACV. 88,500 divide to 0.25.
$34,000.
Okay.
I got 34,000 too.
34,000, right?
Yeah.
Okay.
Yes, 34,000.
34,000. And CMRR in dB will be equal 20, okay, time log, okay, of for 3,400,
410.
right?
410.
So you take the log of that times 20.
90.6.
And 90.62.
Yeah. 19.62.
90.62.
90.6, right?
Right.
Yes.
Sir.
Okay, very good. You say that's just a very, very basic. They not go into too many detail. Okay. Now on that one, you say on that differential amplifier, they want to get only one output. Okay. Single-ended output. However, you get input 1, input 2. Input 1, you get 2 signal. This is one signal. V in 1. This is a VCM1, VCM2. That means 2 signal here. Okay. Basically, this guy and this guy will be the noise. That means they be identical. Okay. So for the differential amplified circuit, so single-ended output, they given, okay, AVD 2500 and the common mode rejection 30,000. Okay, V in 1 500 microvolt IMS. Okay, at the same time of a 1 volt 60 hertz common mode interference signal appear on both input. That means they're talking about this guy here. 1 volt, 60 hertz. Okay? And they want to know, determine the common mode gain, ACM. Express CMRR in dB. And they want to know RMS output. Okay? See, they get the AVD. That means differential gain. And the common mode rejection ratio is 30,000. Okay? And they given you the input 1, 500 microvolt IMS. Okay? And this is the noise, 1 volt, 60 hertz. Okay? They want to know the common mode gain, ACM. Who can get that? I given you common mode rejection ratio, AV D over ACM. So that you already know common mode rejection ratio. Okay? So you want to calculate what ACM equal. So ACM equal AVD divide common mode rejection given to you. That is the gain of the common mode. Okay? And B, common mode rejection in dB equal 20 log of 30,000. Okay? That means 30,000 here. Okay, you get 89.5 dB. Then V in differential equal V in 1 minus V in 2. Okay? So basically V in 1, 500 microvolt IMS minus to 0. You get 500 microvolt. And V out equal AVD times V in differential. Okay, the answer will be 1.25 volt IMS. Okay, so when you get the time, you can go over. Okay. Now, the other example, you know that the noise. Okay. And this is a true signal. V in 1 to V in 2. You can see V in 1 go up, V in 2 going down. Okay? They must be opposite. We see what they try to explain to you. For the differential amplifier circuit show, AVD 2500, common mode rejection 30,000. V in 1 equal V in 2, 500 microvolt IMS. At the same time, 1 volt 60 hertz, common mode interference signal appear on both input. They want to know the IMS output And you can say they do calculation. V in different equal V in 1 minus V in 2. That means 500 microvolt minus 2 minus 500. You understand why minus? The thing is, this input will be opposite. One positive, the other one have to be negative. So that's why minus. You get 1 volt, 1 millivolt, I am at. V out equal AVD times V differential. So take that times 1 millivolt, you get 2.5. Okay? And ACM, the gain of the common mode equal V out divided to V in common mode. Okay? So V out common mode equal ACM times V in. That telling you they get 83 millivolt. So that only telling you the signal coming out will be 2.5 volt IMS. And also the noise still coming out, however, only 83 millivolt. Okay, so basically for the differential amplifier, okay, that means they get two input, okay, and normally two output. However, they're using only one. That's a single-ended. And those signal must be opposite. Okay, and also at the input signal, they get the noise. That's what two signal identical. Same voltage, same frequency, okay? Same phase, considered to be the noise. That means unwanted signal. You don't want that coming out, okay? That's what they call a common mode rejection ratio, okay? That's it. Okay. Any question on this one? Okay, so basically, you understand at we can get next week and the following week. Next week will be Monday on 17. And follow that will be 24. Then we will get a 1 week off. Okay? 1 week off will be from March 30th up to April 7th. Okay? That spring recession. Okay, so any question, anything? Okay, if it's not, okay, I want to stop it today. Next meeting will be the operation amplifier, will be longer, okay? But that's a very basic thing. You have to know how to deal with that. Okay, any question, anything?
No, sir, thank you. So,
Nope, that's we're good.
yeah. So the spring break will be March 30 to April 7, sir.
Can you say again?
March 31st is break.
You mean
Yeah,
the break?
so I mean the spring break will be March 31st to the April 7th.
Yeah, from Sunday, Saturday, March 29 up
Oh,
to April 7th.
Sounds good.
1 week. That is, let's see what they call. That's a spring break. 1 week.
yes, sir. Yes, thank you, sir.
Okay. Okay. Any
Yes, sir.
question? Anything? The
No.
thing is, only 2 weeks, then 3 weeks, then almost we try to get through on of the handout for electronic. Okay. And we can get around May, that 1 month. I will be try to go with you. Make sure you're able to do your level. The thing is, I get a camera at home. However, before we can using, now I cannot using it. I try to working on that. Then I can working guarantee you know how to working on the level for sure. Okay? And try to get as much level as you can. Okay? If you get everything look good, you can take a break. No big deal to me. Okay? So, any more question? Anything? If it's not, so you guys get a very good weekend. Okay?
You too. Thank you.
Yes,
Thank you,
sir.
Mr. Pham.
Thank you.
Bye.
Bye,
Bye-bye.
bye.
Bye.